Of prisms and cylinders. And first thing is, there's no real proofs, okay, in this unit, but they do want you to know how to derive or come up with some of these formulas. So what I say here is derivation means to derive the formula for volume of prism in a cylinder. And we do prism first and then cylinder. Let me start with this. Anybody remember in the past you might have done prism, cylinder? Anybody remember what the formula is? What cylinder? I'm doing prism.
Which was a prism?
Prism is a shape where you extend it, you take a 2D shape and extend it in 3 dimensions.
Base 1 plus base 2? Or divide by...
You're thinking of trapezoid, I think. Okay, well let's see what it is then. Oh, wait a minute.
1/3.
So let's imagine I have a rectangular prism. Oh no, that's pyramid cone. Go on there. Let's imagine I have a rectangular prism. How I get the volume is a prism, a rectangular prism. Let's say it's a square prism. The base is a square, right? And then at every cross section, that's why we did cross section. At every cross section, there's another square, right? There's a square there. Square at all of these points along here, right? So what we can do is if we find the area of one square, so I find this area of that square, I can add up all of the squares all the way up. And now, here, I should correct something. They're not really squares because a square is 2-dimensional. So these are actually 3-dimensional, like very, very small prisms, square prisms. But we just add all these up. How many do I need? I need as many as my height is of my finger. So it's the area of the base times the height.
Base times width times.
Hold that thought for 1 second. So for any prism, it's capital B times H. Now, here's where we learn about capital B. They do say this on the formula sheet. Capital B is area of the base. So somewhere on your paper, just put that capital B is area of the base. So it could be a square. It could be in this one, it's a triangle. Let's see if I go back to others from yesterday where it was, remember, like pentagonal. Here. It could be a pentagon, that's capital B. Rectangle, a trapezoid. Okay, so capital B is you find the area of whatever the base is and multiply it by the height. Let's just do this. So this is very different from little b. Little b they just put base. Capital B they say area of the base. Alright, so do not do little b for capital B. Now you said length times width. Now if it's a rectangular prism, do you remember rectangular it is length times width times height? You probably remember that. Okay, because that is a rectangle or a square, the area of the base, capital B, is length times width. So yes, rectangular prism would break down to an easier length times width times height formula. Other than that though, leave it as capital B. So whatever the base is, triangle here, trapezoid. Okay, and then you add up all of the heights, you add up all of the squares or all the trapezoids, triangles of your height. And that's the volume. It's not really, some of these formulas you can do more work with. This is just understanding base area, add up all the height, add up a height amount of all of those. One other thing I want to mention from yesterday is H is always the distance between the bases. So that's my base and this is my base. H is the distance. So even here, this would be my H.
Yeah.
Right? If the figure is not on its base, it's going to be kind of sideways here. If this triangular prism was on its base, it'd be more like this. Okay, more like that. Then the height would be up and down. But height is not always up and down. Yes?
Okay, so why did we learn that, like, to find the volume of those, it was length times width times height? Why wouldn't we just learn that formula first since it applies to all of them?
This applies to all of them. Yeah, probably because that one's easier. You probably didn't do many more. Did you maybe do a triangular prism, find the volume? You probably, okay, that's why. You probably just did this one and maybe a cylinder. This one, you're right, this is more generalized to any prism. Even like a prism that would be like this, and then extend into 3 dimensions, whatever that would look like. So, right, whatever the base is, and then times the height. So, now guys, cylinder is the exact same formula. That's why we do these together. However, for a cylinder, it is capital B times H, but we know capital B is always going to be a circle. And we know the area of a circle, which is what? Pi r squared, which by the way is on the formula sheet. And all of these are on the formula sheet so far as well. Prism and cylinder are on here. So capital B is pi r squared, and therefore the formula becomes pi r squared H. Same reasoning. How do you get the formula? You take these circles, really disks, because they're 3-dimensional. So very, very small, thin disks, and you add them up. That one, and this one, and this one, and this one. You add all of them up until you reach your height level. So really, we can just do one of those base areas and multiply by the height. That represents adding them all up. Okay. Let's do one example of finding basic volume of prism and cylinder. Any thoughts on developing those though? Let's do a basic one here. I put it in the form of, these are glasses that you can drink from, and I have a cylinder and a square prism. And the question, which one gives you more, basically? So you're going to drink something, a soda or something, which one gives you more? So let's just plug each of these in. Volume of this, oh, and I should mention, I made these same dimensions. Different shapes, but they both have a height of 12 and diameter or side length of 6. So cylinder, pi r squared H. Let's see, the diameter is marked there as 6. You can see it's all the way across. That arrow's in the middle, so 6 is the diameter. So we need a radius of 3. Times the height is 12. Calculator, you're going to use a lot this unit, so you probably just want to make sure to get it out every day right away. 3 squared is 9, times 12 is 108 pi. Now most times I would say leave it in terms of pi for a cylinder. However, I'm going to want to compare this with the prism. So let's go ahead and do 108 pi in our calculator. I got about 339.29. Let's compare that with prism. So I know this is rectangular, so yes, you could do length times width times height. I just want to show you the concept of the capital B though. Capital B is the base area. So actually for a rectangular prism, I could choose left and right, top, bottom, or front, back as my capital B. But I'm just going to choose top, bottom. Therefore, capital B is the base area. It's the area of that square. So 36. Right, 6 times 6. So the capital B becomes 36, and then the height is the distance between those bases, which is 12. Now again, for this one, yeah, it's probably easier just to do length times width times height. 6 times 6 times 12. That would work as well. Okay, in any case, you get 432. And so certainly the volume of the prism is bigger. So next time you are getting a drink, they offer the square prism glass. Choose that one.
Oh, okay.
Because you get more. Don't know how many restaurants offer that, but you should go for that one.
They look a lot cooler.
They do look cooler. Now, it'd probably be pretty difficult to drink out of. You have to like drink out of the corner.
Or you get a straw.
Or get a straw. Okay, let's talk about one more thing and then we'll jump to the back side. Let me talk about this and then see if there's any questions on page 1. Let me take this example before we go over to the bottom there. Oh no. I have 4 books here I have the volume of the books as the 4 books, right? I'm going to slant the books like this.
Oh my god.
Do you think the volume of those books has remained constant?
Yeah.
Yes. It's as simple as that. Cavalier's principle, Cavalier was a philosopher, mathematician. He came up with this principle that says basically this. If you have a slanted object compared to the right object, perpendicular, the volume is constant, doesn't change. Okay, now you got to keep the same dimensions, you got to keep the same base and the same height. Okay, they'll still have the same base and the same height. But if you just slant the object, so I have a stack of papers there slanted, it's still the same volume. Same thing with a cylinder. If I slant it, or even other shapes like pyramids and cones. If you slant it, the volume is constant as long as you keep the same dimensions. This goes back to the cross-sectional area must be the same with each spot, and that's why this works. That's it. Before moving on, I know we don't do surface area, but what do you think? Would the surface area here to the original, would that stay the same or change? Same. Change. Same.
Oh wait, what even is
Wait.
The outer covering, right? The area of all the exposed faces.
Yes. No. It's the same.
It would be different because there's extra area here and here and here. So it still has the top and the bottom, the front and the back and the left and the right. But there's extra area here compared to this. So it actually would change. So this principle only works for volume then. Okay, let's go on to page 2. Anything I can answer that on page 1? So Cavalieri, I'm going to mention that name some more, and you might see it. Probably will see it. I'm not sure about our end of year test if they would mention that name, but good to know. Okay, let's do a few more advanced examples. Let's do the cylinder real quick. So we're going to find the volume of the cylinder and the volume of prism over there. There's supposed to be a right angle there, assuming that this is a right prism. So it's a cylinder. I'm going to write down volume is pi r squared h. And we got a diameter of 9. Okay, since 9 is marked in the middle at the center. And the radius, yeah, that's what we have. So 4.5. And then height of 15. You good with that?
No.
Yeah, okay, that was a test.
Yeah.
I'm sorry, yes, the height is not 15, that's slanted. The height is here.
I was confused on that, so then I
I was seeing if you go.
That's not very good.
Okay.
Oh, no, okay, what do I gotta get you now?
Pranked.
No, food item. So yeah, the height is the distance between the circles there. Bless you.
Thank
So yeah, we have to do Pythagorean here. Well, let's all write down here. 9 squared, making sure 15 is the C. So it's 9 squared plus h squared equals 15 squared. Do a very quick solve. 81 and 225. And we subtract the 81, so it'll be 144. And square root, so it's 12. It's also, guys, remember 345 times 3. 345, so you multiply each one by 3. Let's leave this one in terms of pi. So 4.5 squared times 12. 243. And I think I forgot it on that earlier one. I should be writing cubic units for volume. So I'm sorry, I don't think I wrote it on these two cubic inches. Okay, so we saw that one. Yeah, some past stuff might come back, like Pythagorean theorem. Maybe some tricks. maybe some 30, 60, 90, and 45, 45, 90. Because you can easily make triangles in these, so definitely some right triangle stuff will come back. Let's see in part B, I have a prism. I'm finding the volume, so it's capital B times H. Now the B, capital B, is a triangle. Mm-hmm. So let's do capital B first. It's a triangle. Let's put this triangle. So it's 1/2 base times height. So notice here I'm writing little b. Right? Capital B is area of a triangle, 1/2 base times height. I can move this. Remember the bases are congruent in a prism. So this 6 can be moved up here, and I have an equilateral triangle. Now we've done this once before. This is the second or maybe the third time we've seen it. Area of an equilateral triangle. So I'm going to redraw the triangle here so we can visualize it. They're all 6 for the sides. So if I'm doing the formula, it's 1/2 a base of 6. I'm going to use, this is my base, and this is my height. So base is 6. Then to get the height, it's not 6. I need to do something. The height is an altitude, so it's perpendicular. That's one option. Or, so she said it splits it in half, which it does, makes 3 and 6 there. You can do Pythagorean theorem. Other option is it's equilateral, so it makes 60 degrees here, and 60, 90, and then 30 here. So you can do 30, 60, 90. Remember, you will have these diagrams of those. What about Pythagorean theorem? Yeah, you can do the Pythagorean theorem here. It's called as h, and 3 squared plus h squared equals 6 squared. But I'm going to tell you it's going to be quicker to do 30, 60, 90. Because you look at the diagram, and it's 2x, x, and x radical 3. 30, 60. So this is, yeah, it's just, we have 3, this is 3 radical 3. Now if you did the Pythagorean theorem, you would get radical 27, which is the same. Okay, so that, by the way, that's h. There's 2 h's up here. That's h for the triangle. This h up here will be h for the prism, the height of the prism. All right, let's multiply this out. So these are not distributing the half, just half times 6 times 3 is going to be 9, and we'll keep the radical 3 for now. I said half times 6 times 3.
Half of radical 27 would be, you know? I don't get it.
I'm just doing half times 6 times 3, and you'll get 9. It'll do half of 6 is 3, and 3 times 3 is 9.
Half of 6 is 3. Oh, so 9. Okay. Oh, I got it.
So 9 radical 3. And that's capital B. Finally, h for the prism is right here. Often it's the one you haven't used the entire problem. It's the height, the distance between the bases, which is 17. I'm going to leave my final answer in terms of a radical. 9 times 17, we get 153 radical 3 inches cubed. Now, if you, test or quiz, I would say round to something or leave it in terms of a radical. Excellent. All right. I got a working backwards question, two of those to do to finish up. Anything I can answer on this one, though? Let's finish up with these two. So volume of a cube is not on the formula sheet. I'm going to explain it right here. So it's pretty simple. Draw a cube with me. If you don't know how, I usually start with a square. There's another square that you're going to put back here at an angle. I kind of dot it. First time you might not dot it. And then you just connect all of these. So then I connect these lines. Once you get good at it, I just go like this. I just connect, I draw the lines next, over, down. The thing about a cube is all the sides are the same. all the edges are the same, I should say. Right? So length times width times height, or capital B times H, they're all the same though. I'm going to call it X. So it is length times width times height, right? Rectangular prism, or capital B times H. You can call them S, you can call them X, you can call them L, H, whatever. But they're all the same, right? So length times width times height becomes S times S times S, or X times X times X, which is X cubed. So that's an easier formula for the volume of a cube. Again, S cubed or X cubed is how you usually see it written. So in this example, a cube has a volume. A cube has a volume of 1,000. So let me write the volume formula for a cube. X cubed or S cubed. What is the length of a side? So notice in this one, I'm actually working backwards. I'm not plugging in for X. I'm plugging in for V. 1,000, and then solving the equation. First time we've done this year, you hopefully did it last year. Do you know what to do?
When you just, I honestly just kind of keep like.
Well, don't just say yes and check, like you reason backwards.
My brain's forgetting what the word is, but basically square root, but with a 3.
Okay.
Cube root. That's.
I'd be fine if you said that. I thought you were gonna say like yes and check. What? I thought you were gonna say what number cubed is 1,000.
No, my brain wasn't giving me the word cube
Yeah.
root.
Thank you. No, good job. Because I wouldn't do this. I could give you definitely a more crazy number, and you couldn't guess and check. It'd be a lot more difficult. So cube root. Remember that? No. It's just like square root. It's just like square root, but it's what square root means. What number times itself is 16. This means what number times itself 3 times is.
How do you put that in your calculator?
Oh yeah. So math 4 on mine. Math 4.
Oh.
Now, on different calculators, like, did you find you're going to use the second or control button probably? Who's got the?
I did that calculator.
It's second, and then like right below second. See, it's like a third button. It's like a second here.
No.
Second here.
No.
So I'll be around and I'll help out with that in case you didn't find it, but.
Can't find it on that. Oh, I found it.
Okay. In some of these you might have to fill in. You might have put the 3 in. Okay. All right, so let's go back. It's 10. What's their units? Inches. And let's do one more to finish up. So we'll do one more, and we'll see if there's any questions on the back page. Also, I just want to show you how. Remember, like arc length and sector area, we work backwards. Sometimes to have the arc length, I have to work backwards. Same here. I can give you the volume of one of these shapes: cylinder, cube, pyramid, cone, sphere. And you got to work backwards. So this is the volume of a cylinder. I'll do pi r squared h. And instead of knowing r and h, we know v and h. So they say the height is 2. So I'll put in 2 over here. And we know volume is 100 pi. So we just have to work backwards and find r. And it's just find diameter, so we'll double r. Just like the arc length, area of sector, I'm first going to cancel a pi. I'm really dividing both sides by pi. So I'll be left with 100 equals 2r squared. Yep, just divide by 2. So we get 50 equals r squared. And so we'll do square root of 50 is the radius. 7.1 probably is a decimal. I'm just going to leave it like this. So the diameter is going to be twice that. So I'm going to write it as 2 radical 50. It's probably about 14.2 because this is about 7.1.
It is 14.14.
Oh, okay. Well, 14.1
Same
to
thing.
it. No, not quite. This is exact, so I'm just giving you the rounded values as well.